Geomatics is a set of sciences and techniques, and the word is a recent one. It's a portmanteau word built upon geography on one side and informatics on the other, so everybody knows what geography is about. It is about analyzing everything happening on the surface of the Earth, may it be natural aspects or artificial ones linked to human activities. And informatics is automated information processing through computers. So geomatics is computer sciences applied on the study of ecosystems. Of course, geomatics is a whole set of techniques and sciences, absolutely useful and even necessary for those studying an ecosystem, whether it is related to human activities like I said, such as urbanism, transports, natural or artificial threat prevention, agronomics, or whether it is related to natural hazards, like coastal erosion. Geomatics is a tool that enables to understand how systems work, how they evolve, and to take useful decisions. In order to illustrate those remarks, it's best to take an example, a quite simple one that everyone understands. In an urban environment, there are railway transports and rail stations. Everyone knows that. How is the location of a new station decided when building a new railway transport system inside an urban space? That is an important issue in terms of economical and societal stakes. And geomatics play a very important part in that framework. The issue in urban areas is choosing the right spot for a train station. It can be chosen according to which area is most densely populated. In that case, of course, building a train station is very useful, but it is also very complicated and very expensive, very costly for public finances. On the other hand, in areas little or less constructed, like low-density rural areas, building is rather simple, not expensive, but generally not very useful, unless you want to urbanize new territories. So geomatics is useful if you manage to choose between investing in neutral areas or building where the impact on public transportation will be the most meaningful for the users, for the citizens. Geomatics will then be able to step in and help decision makers to choose the best option, because we know there is knowledge on how the ecosystem of public transportation works that railway users tend to use public transportation more if they live less than 600 meters from a train station, for example, RER station in the Paris region. Geographical information is based on two entities. First, the geometrical formation. Actually, a P-point exists at the surface of the Earth. That P-point is located at the surface of the Earth, which is by and large a sphere, with two values, latitude and longitude. The latitude is an angle between the equatorial plane and the straight line connecting the center of the Earth and the point in question. Longitude is also an angle between a particular meridian plane, that of Greenwich, and the meridian plane passing through the P-point. The first processing to perform in geomatics is to go from that set of coordinates, latitude, longitude, to coordinates that are more easily manipulated inside the plane, in an orthonormal marker XP and YP. An object is also defined by what is called a semantic information. The semantic information is what will give meaning, the geographical reality to the P-point, which is actually purely geometrical. Let's take a train station, for example. It will be represented by a point on the surface of the Earth. On the semantic plan, a train station is defined by information, such as the station's name, like the Gare de Lyon in Paris, or the Gare du Midi in Brussels. A train station can also be defined by the number of daily users, etc. So a geographical object is defined by those two levels, the geometrical and the semantic level. The combination of the two creates a geographical object which type is station, for example. Those objects are aggregated in objects layers. Just one train station doesn't make sense. It's all the stations together with their location and their usage that gives meaning to the whole. So, in the geographical data system, we will be able to enter those objects in the computer, both on the geometrical and the semantic plane. All those objects are entered. They are processed, they are aggregated, filtered and sorted out in geographical layers. And, of course, stored in a database, inside a computer or a computer network. Those geographical layers are used to perform spatial analysis. That is what will give meaning to geomatics and its computing power. Due to the use of computers, for example, there is the station layer appearing with a certain number. There will be 3. We will cross that information with a layer of cluster of houses, coming from Annecy in France, for example, which regularly takes a census of the French population. So that layer of clusters is set in geometrical consistency with that of the stations. Another layer will be applied, an interrogation layer, corresponding to our circles of 600 meters in diameter around the stations, and so we will be able to start a calculation with the geographical information system by saying, how many people live less than 600 meters from each of those stations. Results will then start appearing. Here we see a station bringing 4815 people together. This one is kind of the gold medalist amongst the 3 stations. A station for 3855 people, that's the silver medal. And a third station for 3419 people, that's the bronze medal. So we see that the first that may have cost the same collective price for its construction is useful for more inhabitants than the third one, and the practical reality shows that there is a wide array of useful choices in the construction of train stations. All that is, of course, very useful. Decide on the location of future train stations, of future means of transport. The informatical object is hard to perceive. In this representation is pictured as a blue ellipse, with its green and pink components. To visualize it, whether it is on a map or on a screen, the geographical object is associated with a cartographic representation. Sometimes, the word cartographic object is used. Those cartographic objects can be points. It can be blue squares. So we can work on forms, dimensions, colors, what we call visual variables, and represent it with small meaningful objects, like a train symbol or an RER symbol. So those are the 2 possible representations. So in the end, geomatics is the component of a very important decision-making system that allows specialists to perform calculations, enlightening political choices, particularly for infrastructures, but in a much simpler way. Those are calculations done on a computer for geographical data that will enable to understand all kinds of ecosystems, like the ones I mentioned in this presentation's introduction, regarding agriculture, defense, industry,